Pre-Calc Unit 9 practice test. Just so you know, the last sheet in this packet is this formula sheet, so it's got a little bit of everything. You can see that this curriculum's not letting go of all your identities, and then we got a little Kramer's rule, inverse function going on there. So with that in mind, we're going to start you off with a simplify problem. Now, if you recall, while I was teaching this, to try to help you, I've got a 99% rule where you don't mess with sine and you don't mess with cosine, and then you're like, okay, well then that means I gotta switch this, switch this, switch this, switch this, but you're missing the big picture. If you glance at this thing, you've got a binomial times a binomial. So hopefully you see that and you're thinking FOIL. But under further investigation, we have what's called a conjugate. This is the same as this is the same as this. These things are opposite. And when that's true, your outside and your inside are always going to cancel. So if I went and multiply that, I'd get a negative cosecant cotangent. Here I'd get a positive cosecant cotangent. So those cancel. So I just have to go first, cosecant times cosecant, cosecant squared, and then last, positive times a negative is negative. Cotangent times cotangent is cotangent squared x. And when I look at that, I'm like, whoa, that looks impossible to simplify. My formula sheet's going to be messy by the time we're done with this review, but if you look, we've got the same thing right here. So what does this equal? Well, believe it or not, equals 1. And we're done with that. So, next problem. This comes from your trigonometric identities, but it doesn't tell you which ones to look for. Now, yes, there's an advantage to working with these a lot, because I can see that these are going to come from the double angle identities. So I look at this, and it definitely reflects this. So you have to understand that this problem is simply telling you, take this, match it with this, which it does, and move that way. So first of all, this looking thing is going to simplify to another tangent, and this tells you what to do. This tells you take the whatever angle's given to you, and they're supposed to match, and they do, and double it. And that's all you're supposed to do, just to simplify. This one's very similar to that one, but you look at 1 minus 2 sine squared. I'm ignoring this. I'm looking for just this, and I see it. Right here, which is telling us this whole thing is going to turn into cosine as long as we double the angle. So it'd be 126 degrees. That's all they want for this one. All right, now this one a little more complicated. So this one says determine the solutions, potential huge hint there, more than one, and a lot of students are going to say, oh, I'm going to divide by sine. But remember, you can't ever, ever, ever divide by the thing you're trying to find. We're trying to find theta. So I taught you about that in class. So the first thing we're going to do is set equal to 0. And then we got some algebra challenges. Can we subtract this from this? And the answer is no, because they are not like terms. So that's what this turns into. Notice now we can factor out a sine, and now you can see why it's so important to factor out a sine to get started. And now I've got two scenarios. Number one, sine equals 0, so we'll solve that one over here. And then number two, we got to figure out where secant theta minus 1 equals 0. And every problem can be slightly different. But these are both going to turn out to be quadrantals. Why do I know that? Well, let's take a look at this. What is sine? Opposite over hypotenuse. How can I have a fraction end up equaling 0? The numerator has to equal 0. And we've worked with these quite a bit, so maybe you're starting to memorize these. But 0 and 180, or pi, are two answers where my opposite side disappears. So 0 and pi are two of my answers. Now we go over here, add 1 to both sides. Let's investigate where secant equals 1. Well, what is secant? Secant is the reciprocal of cosine. So if we notice, secant equals 1, which means 1 over 1. We flip it, we'd get 1 over 1. Why is that so important? Because that's my adjacent side, and that is my hypotenuse. So we've got another situation like this, where it must be a quadrantal, because how can my adjacent equal my hypotenuse? Well, before we draw a brand new picture, let's look at this. This right here is my adjacent side, and this is my hypotenuse, and this is my opposite. And my opposite's the one that disappears, so my adjacent and my hypotenuse have to be the same at 0 degrees or 0 radians. So 0 degrees is another answer. How come it's not 180? Because this is a negative and this is a positive, so that would not be another answer. But we got 0 and pi for this, we got 0 for this. So seeing we saw that answer come up again, these are our only answers, 0 and pi. Got to think way through that. All right, so here we are. Number 4 says use your angle or sum identities, and those are right there. So these problems look way harder than they are, but it says simplify and determine its exact value. So here we go. What does that even mean? Well, let's first simplify by looking at these. I got sine, cosine, nope, nope, yep, yep, minus, yep, and then cosine, sine, cosine, sine. So we got a match. Here's our match right here. It's telling us to go that way. So this is going to simplify into sine of u, which is the first degree measure, minus v, which is the second degree measure, and so we got sine of 45 degrees. Now what did we just do? We simplified it. What haven't we done yet? We have not determined its exact value. It is not time to stuff this in your calculator. Exact value means take your spinner, spin it 45, which means right to here. By the way, this won't always be that easy. It could be 135, it could be 210. But here we are, 45 degrees up. Finish your triangle, come back to the x-axis. If that's 45, this is 1, 1, square root of 2. What's sine? Opposite over hypotenuse. So that'd be 1 over the square root of 2. So let's get that square root of 2 out of there. We get the square root of 2 over 2. So this is my exact value, and this is the answer simplified. So I'll be looking for both of those. All right. We are finally into the things we've been working on, matrices. So let's go. It says if A is this matrix, B, C, D, compute the following. A times B. Well, remember we take the first row of A, that's here, multiply it through all the columns in B, but there's only one column. So that's 4 times negative 5, which is negative 20, negative 3 times 2, plus a negative 6. So that answer would go in the upper left-hand corner of our new matrix. But then notice there are no other columns, so we slide down to the next row and do the same thing. 6 times negative 5 is negative 30, plus 3 times 2 is 6. So that'd be negative 24, and that's what goes here. But again, there are no more columns to multiply this through, so we're done. Now it says flip it around. Well, it's negative 5, 2 times 4, negative 3, 6, 3. Now some of you are already sniffing this out. In this row, we've only got one element. In this column, we have 2 elements. So immediately, our first attempt, our first look at it, we should say, guess what? This is impossible. Not enough information in matrix B. 4D is pretty simple. Just multiply everything by 4. So 8, negative 4, 16, 0, 12, negative 16. That's all they want. Just for you to know that you can multiply a matrix by a number, just like you used to distribute things through binomials or trinomials in algebra or pre-algebra. A plus D. Well, here's A, here's D. Now, if you're going to add matrices, and you look at this is a 2 by 2, and the matrix is a 3 by 2. If these don't match, you can't, because all the elements in this matrix must match this one. So I could have added this to this if that was the problem, but that's not the problem. So again, this is impossible. All right, so what if it was C plus D and we were to get started? Well, then you would just add this to this and you'd get 6. This to this, you'd get -4, and so on and so on. All right, here comes a tough problem. Number 6, solve it using Kramer's rule. Let's zoom in for this one. All right, so the first thing we want to do is find D. And Kramer's rule is right here, but I'm not spoon feeding you everything. But it does give you D right here in a formula kind of a way, but we've worked with it enough. We take off all our coefficients, 2, 1, -1, 3, 2, 2, 4, -2, 3, and we got to figure out this 3 by 3 here. So we take the upper left one out. Remember, there's an invisible plus because it goes plus, remember, plus, minus, plus. That's what we got to remember as we go through this row. So then we make an invisible line, we're left with this, 2, 2, -2, 3. At any time, any one of us can make a small mistake. Minus, take that 1 out, line, 3, 2, 4, 3. Now we're going to take then it goes plus, we take that out, line, 3, 2, 4, -2. Now we got some 2 by 2s to figure out. So this is 2 from here. 6 minus a -4 is actually 10. Minus 1. This is 9 minus 8, which is 1. And then plus a -1. And then we get -6 minus 8. It's -14. So let's figure this out. This is 20 minus 1 plus 14, which is 34 minus 1, which is 33. So I know D equals 33. So now we're going to find dx. Now how do we do that? We take all of our constants and we replace our x column, because these were our x coefficients, y coefficients, z coefficients. So we go 1, 13, 9, and then everything else is the same. And we're back to the drawing board. So remember, it goes plus, minus, plus. What do I mean by that? Well, there's a plus in front of this when we take it out, so we don't change it. Line, 2, 2, -2, 3. Minus, no matter what we pull out. And there's a 1. Line, 13, 2, 9, 3. Plus, pull that out. Line, 13, 2, 9, -2. Now, as long as I haven't made a silly mistake, this should work. So here we go. 1 times 6 minus a -4, which is 10. Minus 1 times 39 minus whatever that is, 18. So that's 21. Plus a -1, and that's -26 minus 18, which is -44. So if we take a look at this, it's 10 minus 21 plus 44. Add the evens, 54 minus 21 is 33. Now, remember what our formula says right here. X equals dx over d. So, over here, x equals dx, which is this 33, and you love it when it works out like this, over d, which is 33, which is 1. Now the thing I showed you guys all in class, whoops, I didn't show my work on that one. So this is dx and this is d. So that's dx and that's d. We get 1. Love it when that happens. Once you've found one of your variables, what I think the easiest thing to do is pick your favorite 2 from the original. I'm going to pick the top 2 and I'm going to plug a 1 in for x. So that'd be 2, try to squeeze it in here, plus y minus z equals 1. If I subtract 2 from both sides, I get the simple y minus z equals negative 1. Yes, we could find dy by using this. Yes, we could find dz by using this. But this is way simpler in my opinion. So now I'm going to put a 1 in right here. So that'd be 3 plus 2y plus 2z equals 13. Now if I subtract 3 from both sides, I get 2y plus 2z equals 10. Now look at this one. This one, I'm going to divide everything by 2 and then bring it down here. So I get y plus z equals 5. And if I just add these together, y plus y is 2y. My z's canceled, just literally fell out on a plate. 4. So y equals 2. Now that I know x and I know y, I'm going to plug it into the top one. So 2 times x. I guess I could have just used, if y is 2, just plug it in here. But seeing I got started, plus y minus z, make sure your z's look like z's and not 2's, equal 1. So that's 2 plus 2, it's just 4, minus z equals 1, subtract 4, subtract 4. I get negative z equals negative 3, so positive z equals positive 3. Again, if I would have just plugged that 2 right in here, I'd have had 2 plus z is 5. Well, z has to be 3. Would have been a lot easier. But 1, 2, 3. Huh, didn't try to make that happen. All right, let's pause that. That's it for part 1, you guys.